I'm going to be showing you a little application. Um, so we are going to continue looking at object-oriented programming concepts. We looked at polymorphism last week, where we did an override of a method from the base class. I want to show you a couple more variations on that. We are going to cover like static classes and also abstract classes in this particular video. So let me just step you through like what I have first of all. Here is the class that I've written. The code will be in GitHub and we'll be making some changes just to keep the video short. So for example, if I were to write like an animal class, all these are going to be the variations in animals, right? We can have birds, fish, reptile, or mammals. So let's say like those are the four classifications. So animal has like a species and family, something like mammal is a species. Let's say that I'm not like scientifically correct here, and let's say the family is like a lion, whatever. So and then some of the features of animals are going to be like a tail, whether an animal has a tail or not, whether an animal has feathers or not, whether an animal has legs or not, and if so, how many legs, and whether it has fins or not. So these are some of the features. So for an elephant, tusk is another option, right? So these are some of the characteristics that define an animal. Some of the methods for animal could be like eat, make a sound, hunt, whatever it is, graze. Those are all some of the activities around an animal. So this is kind of like the baseline for our thought process of what we are going to be doing with abstract classes and why we need that. So for example, if I were to create classes like this, animal class, bird class, fish class, mammal class, and reptile class. So that means that each and every one I can create an object on. I can create an object called animal. I can create an object called bird, fish, mammal, and reptile. So that is what I've done so far. And let me just show you really quick what I have. So this is the animal class. So I have the species here, and then family is a private variable, and then I have a property around it. The rest are all like just get set booleans, has tail, horns, fins, and feathers. And then I have the basic constructors for all of them. I have three different constructors: a default constructor with no parameters, one with just the species, the other one with species and family. So depending upon like the family, if it's an elephant, then I may set the family trait to have tusks. If it's a fish, I may say has fin is true, has legs is false. So I can do like manipulations like that. So just for the sake of keeping this video short, I don't want to go into the details of what I'm doing, which you can do here. So let's think about it for a second. If we were to look at all of this, let us say that any time a new species of animal is discovered, we want it to like have a branch from here. We want it to have, we want it to have a branch from here and a box added here, which means we have to create a new class or anytime there is a new species. Okay, instead of that, the other option would be for us to continue using this animal class as a generic class. What happens when that happens is the data that can be entered for the animal class may not have the same integrity as the ones for the bird, the fish, the mammals, and the reptiles. The reason being it is way too generic. So that is the reason why any time a new species is created, we want it to be created as a subclass of the animal class. And we do not want anyone to create any direct objects from the animal class. So this animal class, we don't want it to have any kind of objects. No objects. So we want objects to be created only from the children, not from the parent. So that is what is called as abstract class. An abstract class is a class where you really cannot create an object of that class. That class is there like a blueprint to be consumed by the other baby classes. And that is what abstract class is all about. So let me show you without abstraction how this looks and with abstraction how this looks. So So what I'm doing here right now, this is not an abstract class. You can see there is nothing that says this is an abstract class. This is just a regular class. And then I have derived classes, the bird, fish, mammals, reptiles, all of these guys, just to give you an idea. And I have created, like, let me just say, like, for example, a reptile, I said number of legs is 4. And then I said no horns, no fins. All reptiles seem to have tails, and then no feathers at this point. There could be a variation in future, but that's for this particular example, let's leave it like that. So mammal, again, like depending upon what kind of mammal, it can have horn, tail, or none of them. If it's an elephant, it'll have a tusk, tail, stuff like that. And then we can have like a default. You can see that I've used a switch statement here. So this is how we like combine all the concepts we have learned in this class into a project. So we have all these little classes. So let us just try here and then try to create objects. So right now, animal is not an abstract class. So we use the new keyword and then the name of the class. This creates an object. This is an object. A1 is an object. So I have a method called intro. So I did not set the species. I did not set the family or any other content. So this is kind of like a very base level of animal class. So let's do a read key on that guy so we can actually immediately look at what's going on. So the intro is a method that just writes some of the parameters, the properties that we set. So instead of animal class, so if I were to write like a bird, and then I do an intro on the bird. So let's do one for each. Okay, fish F1. The one other thing I have is a reptile. Intro is a method that I have done an override on. So we covered this in the last video. So here's my method called intro. It just shows the base class shows the family and the species. And then the derived classes add their own additional information after calling the base class. See, I'm calling a base class here, and then I'm doing my own extra things for this particular class. The most important thing here that includes polymorphism. Polymorphism is where the same method is being implemented differently in different derived classes or children classes. Okay, so we are using the override keyword in the child class, and then in the base class we are using the virtual keyword. Okay, so this is just general, right? We covered this before, so you're all familiar with this. So this is just basic, where you are able to create an animal class, bird class, mammal, fish, and reptile. All 5 different classes we can create. And then I can just show you like how the data comes out. I want you to understand when to implement an abstract class. And I hope this example will clarify that. So my program compiled properly and it's trying to bring up the console. So this is for the animal class. See, it says species is none, family is none. Now for the bird, I didn't say what family it is, so they are all going to say family is none. And then they are going through the default. So let's change this so we say what kind of animal we are creating. So I'm going to say the bird is emu, the mammal is elephant, the fish is goldfish, we're going to have a lizard family. So now let's see what happens when we run the code. Okay, here's my application. Like I said before, species and family are none. So now I said the bird is emu, which means I have code there that says, okay, a bird has feather and wings. They have two legs, right, bipedal. And then emu is a specific variety that cannot fly. Now, elephant. Elephant has no horns, it has a tail, it has tusks, and it has four legs. So we are getting a little more specific about, depending on the family, there are some decisions made inside the code. So this one is about goldfish. It has fins and no legs. And then the reptile family, lizard, and they have a tail. So just some concept that we are adding just to make this a little more interesting. So the same intro method is implemented in different ways, and that is called as polymorphism. The only thing I want to bring to your attention right now is that the animal class, by letting anyone to create objects, it is not doing any favor to anyone. If your classes or code is only as good as the data you capture, the integrity of your data is absolutely important. So to create like a dummy animal class with no family, no species, because at the moment you decide like what species it belongs to, it's going to become a child class, right? Like I said, if there's like dinosaur, for example. So dinosaur is not a reptile, I believe. So dinosaur has its own class. So if I put a dino, immediately when that's a new species, it has to be a derived class because it has not only that, but it has behaviors, the kind of food it eats, the kind of, the strength it has or the speed with which it runs, all those properties become something that we can create for a class. So there is absolutely no reason for this animal class to exist as an object. It makes sense to have it as a class, but it does not make sense to have it as an implemented as an object. And that is where abstraction comes in handy. So right now what we can do is we don't want this because it doesn't benefit anyone. Anytime you classify an animal, it is going to go into one of the subclasses. So the parent class is just going to be like a blueprint. We don't have to actually create instances of that particular class. So what we can do for that is where abstraction comes in. So you go into the animal class and then you put the keyword abstract. The moment you put the keyword abstract, okay, let me just go and undo what I did here. Let's keep this on. Okay. So let's go into the animal class and I made it abstract. The moment you make a class abstract, if you try to create an object, you get an error right now. My old code created object, so it is saying cannot create an instance of the abstract class or interface. So this is no longer possible. So what this eliminates is those instances that are useless, that the data is that there's no data integrity for those, and so we are trying to eliminate that and keep our data very clean. So that is the reason why we go for abstract classes. Abstract classes can have abstract or non-abstract methods. For example, there is no problem with the method we created here as a virtual method. There is absolutely no problem. So you can have this is a non-abstract method, and this is perfectly fine. There is no problem in having a non-abstract method inside an abstract class. But what about this one particular method I have? It's called as set family traits. So if you see here, I am doing nothing in the base class. All the implementation is there only in the child class. So here, all this code, I have functionality defined inside the derived classes. Derived classes are the baby, the children, right? So I have set family traits defined for birds, defined for reptiles. So for each one of them, it's doing a different thing. Okay. So in that situation, what happens is it becomes useless to write any code related to that particular method inside the base class. That means all I'm doing is just for the sake of having some base, just to have a blueprint, I am just creating a virtual method and then it does nothing here. A better way of doing it is to make this abstract. Once you say it's abstract, that means there can be no code for this inside that method. It is just going to be something that all your derived classes have to override. They have to override the set family traits. Okay, we are not going to specify what it is supposed to have. It is only a signature. It is only in the blueprint. There is absolutely no code in the base class. Okay, so that is what an abstract method does. The abstract method of the base class is just like a skeleton, like a signature that is available, and then it is up to the derived classes to implement them. So I have implemented this set family traits in the mammal class, in the reptile class, so on and so forth. You can see all of them. And then when you have time, just go and take a look at what code I've written. It's just something fun that I've written, nothing crazy. So that's the whole idea of an abstract class. So now if I go and try animal A equal to new animal, I get an error. So it wouldn't let me create any object of the type animal. That doesn't affect any of my other functionality. I can still say, for example, here, I can still say b1.set family traits. I can say that set family traits is available because it's a public method, so it's available for me. The only thing that's not available for me is my ability to create an animal class. Also, instead of this having like a dummy content, we said we will, because our abstract class is not going to implement this method, it is up to the derived classes to implement this method. That is different than this intro method, because in this intro method, we have some code from the base class that we can reuse, and the rest is going to be on top of that, like you can see here in the mammal class. So I am calling the base.intro, and then the base.intro actually has code inside it. The rest is all like additional stuff I'm adding on top. So it all depends on like what the requirement is for the particular method, or what's the business requirement. And then you can make a decision if you want to have an abstract method or if you have to have like a non-abstract method inside your class. One other thing I want to show you is going to be the how to write code efficiently. Let me show you this animal class, for example. Let's look at the constructors very quick. I have a constructor with no parameter. It is setting the species and family to none. Then I have a constructor with one parameter, which is taking the species, setting the species, but setting the family to none. Then there's a third one that's setting both the species and family. So this is 0 parameter, no argument, 1 argument, and 2 argument parameters. But here is the problem. We are repeating some code here. So there could be, I mean, this is a simple example. So our constructors are having little code, but if you have a complicated business requirement, your constructor could be a lot more complicated than what we have here. So the whole idea of writing code is to try and minimize the number of lines we write and try not to be redundant in our code. Anytime we see redundancy, there is an opportunity to make it better. So usually what you can do when you have situations like this is something called as constructor chaining. So we can chain the constructors, so one calls the other. That way you get the benefit of writing code once and reusing it. So when you are trying to do like a constructor chaining, always look for the constructor with the most number of parameters. So this guy will stay, but these guys will change. These two guys will change. So let's look at this guy. So he is taking species, family, and whatever is coming inside the species and family, he would set it here. So we are going to use this guy for the other two constructors. So how are we going to do it? So let's delete this code. So here all I'm doing is I'm getting species. So I'm setting family to none. So instead of this code, let's delete this. What you can do here is you can say this. So what this does is instead of defining what happens here, we are just like routing it from the one constructor parameter to the two constructor parameter. We are sending species over here. For the family, we are setting it to none. So when you say this, you are saying in this particular class, find me a constructor that has the two parameter signature, and then send these as the arguments. So this guy here, again we'll delete these two, will be the same as saying this. We want the two constructor parameter, right? We want this guy. So the first parameter is none, the second parameter is none. So that is how you chain the constructors. So now see, all the code will always get routed here. So we don't have to keep writing redundant code. Let's go and take a look at how we can rewrite this mammal class. So here, see, again we have like repeating, right? So let's pick the constructor that is the one with the most parameter, which would be this guy. So we keep this guy as is, and then we delete this guy. So instead of calling the base here, let's call this parameter. So we have to send family. So we have to send family. What is the family? Family is none. This would call this parameter, this one. So family coming through as none, and then we are calling from here the base, which would make the species as mammal and the family as none. So this is another chaining. So you have to know the difference between calling the base and calling this. When you say this, you are referring to your own class. You are referring to the constructor that is taking one parameter. Okay. So if you call base here, instead of this guy, instead of this, you will miss these two defaulting. So inside the derived class, make sure the one parameter should be the only this constructor should call the base. The rest can all call this particular constructor. Again, I'm deleting this. This would be the family, which is none at this point because I didn't pass that information. So this is calling, the first one is calling this guy, and this guy calls the base. So keep it that way. So this is called as chaining. And the main idea is so that we are not redoing code. We are not rewriting code again and again. So let's see this guy again. So if you want to look up, you can look up constructor chaining. So this looks good. Anytime you catch yourself writing something multiple times, then you know that there's an opportunity. There is definitely an opportunity. Let's run this code just to be sure that our changes have not broken anything. So family is emu, species is bird. See, all of that is working fine. This is exactly what we want. Even though we changed our constructor around, it is still working fine. So that seems to work fine. All good. So that is called as constructor chaining. The third concept I want to go over is about static classes. We have covered the static methods and static properties in another video before. So static means one copy. That's the whole idea of static, right? So you don't keep a copy for each and every object. You just keep one copy at the class level as opposed to at the object level. So that is what static method is all about. So let's think about it for a second in terms of a static class. Why would we need a static class? And what is a static class? So a static class is a class that cannot be inherited from, that cannot be instantiated. So it is kind of like there, but you can't do anything with it. It won't behave like a class. Okay. So for example, this is something you're all familiar with, this console.read key. Is console an object? No, it's the name of a class. And you're able to directly call a method from this console. And how is that happening? It is happening because this console, system.console, is a static class. Let's go into the definition, like peak definition. So what I did was I clicked on it, right clicked, and I said peak definition. So peak definition keeps the definition right here so you can scroll through. Look at this particular sentence. It says public static class console. So a console, we are not saying console C equal to new console. We are not using how we did this bird. The bird is a class. It is not a class, so we are creating an object. So B1 is an object, but console is not an object. Console is the name of the static class. So how are we using this console? We are using this console as a utility class to get some work done. So whenever we say console.read key, it waits for us to give input. It has nothing to do with a specific object or whatever, right? We are directly calling it at the class level. We are having a bunch of methods for this particular class that we can call on anywhere in the code. It doesn't care if it's an object, a baby, a child derived class, or whatever. So let's take a look here. So there is a window with property, is output redirected property. There's a whole bunch of properties here that we can see that are part of, and they are all static inside. Every one of them is also a static property. So the whole idea is of a static class is like it can be like a utility class. You can use it by calling it as the class name dot, similar to the static method we saw before. The static method that we saw before was part of a non-static class. In this particular video, what we are looking at is the static class itself. So I have a species helper here. I just created this class. This class is going to be like a helper class that we can call from our particular animal or like mammal or anywhere else. So let us say like this guy is going to just give us generic information. So this could be something like when you go into a museum, you click on that button and it gives you information about like in general about species. It is not going to give you information about a specific animal, but it just tells you what the species does. What does like a bearded dragon do? What are some of the traits of a bearded dragon? Something like that, something very generic information. So I just wrote like a simple console.writeLine here. So the main thing you have to watch is static here at the class level. We said it is static, which means all the methods are also going to be static. Okay, so I created a whole bunch of methods. These are going to be generic. That is what you have to remember. We are creating some generic methods inside a static class. This could do like calculations if depending upon like, if you have like an accounting class or something, you could have a helper function that does addition, subtraction, multiplication, division for you of objects or whatever it is. But it depends on your particular situation. Because I have like a species class, I said I wrote a species helper. So how would we call this guy? So let us just call the static class. A static class has to be called by using the name of the class, species helper dot, and that will open up all the different methods that are available. Give me information on this cold-blooded creature. Then I can say species helper dot, and then I can say what's a family. What does it mean when we say family? So it can give you some generic information about that particular class. So in terms of like more complicated logic and all that, you could have a static class be able to add, two numbers that are like properties of, like for example, like if you like take two animals and then you want to add their age together and say like, sometimes we say like the total age of all these animals is going to be, whatever. If there is a functionality like that, you can use it for that. It doesn't just have to be like writeLine, console.writeLine. You can actually have some more logic inside those methods. But I just want you to understand it at the conceptual level, what a static class does. And even the console is a great static class The other one you can look at is like math dot, or you can say, what is it called? String dot compare, string dot concat. It doesn't care what you're passing in. As long as you pass two strings, it is going to add those two strings. It is going to format the string. So these are all static classes. Okay, any type of utility type of classes are called static classes. They would have just a collection of methods that will provide useful for your particular application. So that is what a static class is all about. I hope this was all helpful.